My beloved students, good morning and welcome to this session. I hope you all are fine. In the last three sessions, we talked about some important indeterminate form for calculating limiting value. And these indeterminate forms are uh, 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, infinity power 0, 1 to the power infinity. All these terms are known as indeterminate form. Today's discussion and upcoming two discussions has been arranged for those students who read in class 11 and 12 and honors first year student related to math. Today we will have to discuss how to remove this indeterminate form from a limit. So, dear student, we are going to understand how to remove indeterminate from the limit. However, then students, let's start discussion. At first, we take an example, which is very simple example, and it is applicable for HSC level students. Limit x tends to pi by 2 cos x by cot x. We want to calculate limiting value of this function at x equal to pi by 2. We know that when x equal to pi by 2, then cos x equal to 0. Also at x equal to pi by 2, cot x is 0, which is an indeterminate form. So if we want to calculate the limiting value, then we will have to remove this indeterminate form from this limit. So as a HSC level student, we can easily remove this by trigonometrical transformation. So we can rewrite this limit x tends to pi by 2 cos x over cos x divided sin x, which is formula of cot x. Then we can write limit x tends to pi by 2 cos x into sin x over cos x. Now we can erase cos x. So limit has become x tends to pi by 2 sin x. We know that when x tends to pi by 2, then sin x goes to 1. So the limiting value is 1. So this example was a very simple example. For honors class student, you will have to face higher order problem. Then you will have to know a formula or a theorem which is called L Hospital's rule. So dear student, and now we discuss L Hospital's rule for honors class student. Suppose we have to find the value of the limit x tends to a f of x divided g of x, where the value of f of x at x equal to 0 and the value of g of x also at x equal to 0 is 0. That is, at x equal to 0, the value of f of x, that is f of a equal to 0. Also at x equal to 0, the value of g of x, that is g of a equal to 0. So this form has become 0 by 0, which is an indeterminate form. Now we would like to remove this indeterminate form from this limit. As a student of honors class, we know Taylor's theorem. by Taylor's theorem, we expand a function in a series, whether it is finite or infinite. So now we can write with the help of Taylor series, f of x can be written in a series which is f of a plus x minus a divided 1 factorial f derivative a plus x minus a whole square divided factorial 2 f double derivative a, and so on. It can be finite or infinite series. Similarly, g of x can be written g of a plus x minus a, similar procedure, g derivative a plus x minus a whole square divided factorial 2 and g double derivative a plus, and so on. Now, one thing is very important. We know that the functional value of f at x equal to a, sorry, it's not 0, it's a, at x equal to a, f of a equal to 0. Also, g of a equal to 0. Then we can say that since these two terms are 0, so this will be eliminated. Therefore, we have another expression, limit x tends to a, x minus a f derivative a plus x minus a whole square divided 2 factorial f double derivative a plus dot dot, similar expression, x minus a g derivative a plus x minus a whole square divided 2 factorial g double derivative a plus dot dot. Now we see that x minus a, this term is common in the numerator and denominator. So if we take common x minus a from both numerator and denominator, then this term will be erased. So we can write limit x tends to a, here f derivative a plus x minus a divided factorial 2 f double derivative a plus dot dot. Similarly, g derivative a plus x minus a divided 2 factorial g double derivative a plus dot dot. Now, if we put x equal to a in this expression, then we see that a minus a, that is 0, a minus a, that is 0, and all terms except f derivative a in the numerator are 0. Similarly, except g derivative a, all terms are 0 when x equal to a or x tends to a. Then we can write this limit x tends to a, f derivative a divided g derivative a, which indicates that f derivative a is differentiation of f at x equal to a, g derivative a differentiation of g of x at x equal to a. This formula is known as L'Hospital's rule. That is L'Hospital rules. That is L'Hospital's rule is a limit x tends to a, f of x divided g of x equal to f derivative a divided g derivative a. Here one thing is very important. This theorem is applicable if f derivative a divided g derivative a both exist. If f derivative a and g derivative a does not exist, then we cannot follow this formula. So dear student, this is L'Hospital rules for honors classes student. So if we discuss the previous problem in this L hospitals rule, then we see what will be happened. Our previous example was limit x tends to a cos x over cot x. Cos x over cot x. Now, if we would like to apply L hospitals rule, then we will have to differentiate both numerator and denominator with respect to x. Since cos x equal to 0 and cot x equal to 0 at x equal to pi by 2, then this is an indeterminate form. Now we would like to remove this form by L hospitals rule. So L hospitals rule is limit x tends to a f of x by g of x equal to f derivative a divided g derivative. So we will have to differentiate both numerator and denominator with respect to x. So derivative of cos x we know minus sin x. Also derivative of cos x we know minus cos x square x. Here by L hospitals rule. So by L hospitals rule we can calculate this. Now at x equal to pi by 2, sin x equal to 1, that is numerator value is minus 1. At x equal to pi by 2, cos x square x. Cos x square x at x equal to pi by 2, which is also 1, that is the denominator is minus 1. The result is 1. So both the result are same. If we follow trigonometrical transformation, then the 0 by 0 term is removed. Also 0 by 0 term is removed by L hospitals rule. So the limiting value goes to 1. Here another thing is very important. If f derivative and g derivative is also 0 by 0 form or another indeterminate form, then we will have to follow L hospitals rule again and again. Therefore, we can write L hospitals rule. L hospitals rule, limit x tends to a f of x over g of x equal to f derivative a and g derivative a. If here f derivative a and g derivative a are also 0 or any other indeterminate form, then we will have to again differentiate this f double derivative a, g double derivative a, and so on. So dear students, we can take another example on this context for honors classes student. Limit x tends to 0, limit x tends to 0, e power x plus e power minus x minus twice x divided x minus sin x. X minus sin x here, not plus minus. So we see that at x equal to 0, the value of numerator e to the power 0 minus e to the power minus 0 minus twice into 0 divided 0 minus 0. E to the power, that is 1, e to the power minus also 1 divided 0, that is 0 by 0, which is indeterminate form. Now if we would like to remove this indeterminate form, then we will have to follow L'Hospital's rule. L'Hospital's rule, limit x tends to 0, e to the power x, differentiation of e to the power x with respect to x is e to the power x minus differentiation of e to the power minus x minus e power minus x, that is minus e power minus x minus 2 divided 1 minus differentiation sin x equal to cos x. Again, we will have to check the value of function at x equal to 0. Let us see that e to the power 0 plus e to the power minus 0 minus 2 divided 1 minus cos 0 equal to 1. 1 plus 1, 2 minus 2, that is 0. 1 minus 1, 0. So we see that the indeterminate form remains unchanged. Since indeterminate form remains unchanged, then we will have to follow this rule. So that is, we will have to follow L'Hospital's rule again and again, which is indeterminate form 0 by 0. So again, applying L'Hospital's rule, we get differentiation of e to the power x equal to the power x. Differentiation of e power minus x minus e power minus x divided 1 0 minus cos x, that is plus sin x, that is the value of this function at x equal to 0, e to the power 0 1 minus e to the power minus 0 also 1 divided 0 plus 0, 0 by 0, which remains unchanged. Then we will have to follow L'Hospital's rule again. Again, by L'Hospital's rule, limit x tends to 0, differentiation of e power x minus minus plus e power minus x, differentiation of sin x equal to cos x. Now the value of this function at x equal to 0 will be e to the power 0, that is 1, plus e to the power minus 1, that is 1, divided cos 0 1, then the result is 2. So we successfully removed the indeterminate form from this limit, and the result is 2. So dear student, we can easily remove indeterminate form by applying L'Hospital's rule again and again on a limit. Therefore, we can see that if we would like to compute a limiting value of a function at a certain point, if this function is undefined at a certain point, then we will have to remove the indeterminate form by trigonometrical transformation or algebraic transformation or L'Hospital's rule. So dear student, this was today's discussion, and I am concluding this session by inviting you to watch our next video. Thank you very much.